Here, we're going to explain the solution of the math challenge that I gave in my stop sign video. So here, in this drawing, is a regular octagon just like the stop signs that we measured. The orange line that I drew, the short diagonal, is the shortest possible diagonal that can be drawn on the octagon. The red line, the line I measured on the stop signs, is the medium diagonal, which is the medium-sized diagonal on the octagon. And the long blue line, the long diagonal, is the longest possible diagonal that can be drawn on the octagon, the diameter. The purple line, the apothem, is supposed to measure half of the medium diagonal. And the apothem is the distance from the center of the octagon vertically down to the side. And it must be perpendicular to the side as well. And of course, at the bottom, the side is the side length of one of the sides of the octagon. So how do we figure out the area? So we can use the apothem and side to figure out the area. We'll call the apothem A and the side S. And using the formula for the area of an octagon, using the apothem and side, the area of the formula of an octagon is A equals to 4AS. But hold on, this is a regular octagon. All the sides and angles must be the same. So this means that the ratio of A to S is fixed. And in fact it is. It's a fixed ratio of 4 to 3. This means that this 4AS can be simplified to 4A times 3/4 A, since S is 3/4 of A. And this simplifies to 3A squared. So now we have our new formula for the area of the octagon just using A. Now we need to figure out the ratio of the areas of the octagons. So we can call the apothem of the bigger sign A and the apothem of the smaller sign A prime. So obviously we're trying to figure out the area of the bigger sign over the area of the smaller sign. That's what we're trying to figure out in the challenge. And using this 3A squared formula, we'll find out that this equals 3A squared over 3A prime squared. A represents the apothem of the bigger sign, A prime the smaller. Since the 3's cancel out, we're left with A squared over A prime squared. And this can simplify to A over A prime all squared. So since the medium diagonal length of the bigger sign was 47 inches and the median diagonal of the smaller one was 23.5 inches, we know the apothems of both of these octagons or signs by using this. Half times 47 over half times 23.5. We can just cancel out the halves, and this equation will equal 2. Substituting back here, 2 squared equals 4. And since we only used A to measure this 4, we only needed one of the lengths that we showed in the beginning of the video to figure out the ratio of the areas of the octagons. How cool is that? Now we have our final answer at 4 to 1. So I hope you learned something from this formula and the formula for the areas of octagons. And I'll see you in the next video. Bye!